Okay, hello. Thank you, everyone. We're going to be talking about Zupass PCDs with Ezekiel. So my name is Casey. I am a core developer on the Ezekiel team, and I am focused on user and developer experience. And if you're interested in ZK and ZKML, please check out our Telegram and our Discord. We'd love to help you get going building your next ZK project. And if you want to ask me anything, there's my email, cs@ezekiel.xyz, and I am current handle on pretty much all platforms, so hit me up. Okay, so basically the problem is set membership, right? And we're trying to prove that we belong to a group, and set membership plus PCD is great because it allows us to prove that we're in that group without revealing anything about our identity. But building set membership circuits and verifiers requires domain-specific knowledge, like a specific language, such as CIRCOM or a framework like Halo 2. So we wanted to see if we could accomplish the same task with a simple Python script. This is the wrong one. Boom, boom, boom. Great. Better late than never. So, so easy, even I can do it. I know very little about ZK circuits and very little about AI. So give me a break with your tough esoteric questions. So let's go. Whoa, I lost the feed. All right, so let's talk about the code. The first, like I was talking about, this is our PyTorch approach to set membership. So we define a model in PyTorch, and it's really simple. It's going to take two inputs. One is an individual who's trying to test whether he's part of the set, and the second is the set membership. Then the members is a tensor, and so we'll do a tensor operation subtracting the individual from the members tensor. If the individual matches any of the members in the tensor, that would be 0, right? A minus A is 0. So we'll then take the product of everything in the tensor. If anything in that tensor is 0, then the membership test will be 0. That's it. That's the whole model. And then what we do in Ezekiel is we say that we want to hash the X value, which is the individual. So what we're saying here, semantically, is that if you know the preimage, I know a preimage that hashes to something that is known in the set. So that's really what we're proving. And the way we do this here is on the next line, where we fix the output value in the witness file. So we call Ezekiel generate our witness, and then we try to set the outputs on the witness. We're going to set it to all zeros. So again, if it wasn't 0 in the membership test, then when we try to set it to zeros, it's fixed, so it'll fail when we try to verify it. But if it was 0 and we set it to 0, then when we verify it, it passes. That's all we do. Okay, so I'm going to take you really quickly through the system architecture of how we use Zupass, and then try to do a quick demo, and hopefully everything doesn't explode. And that's it. So we created an Ezekiel PCD, a secret PCD rather. So what the user does is they use a consumer application, tell it the preimage they want. This is your secret phrase. And then sends that preimage to Zupass with the request to create an Ezekiel secret PCD. We also are going to hit our set membership service and get the settings scale. And then using our Ezekiel engine client-side package, we're going to pass the preimage and the settings data to the Ezekiel Poseidon hash function. Then we get the hash, and we'll register that to the set membership service. Then we're going to create an Ezekiel display PCD. This doesn't really do too much, but it's important for the group PCD we'll see in a second. So we create a display PCD for that secret PCD, and all it basically has is the React rendering logic. So when we open the display PCD, we're going to, on the fly, create a EZKL group PCD. The way this works is it gets the pre-image from Zupass client. It creates a group PCD, a new one, every time you open it. What it does is it goes to the set membership, it gets the compiled EZKL model, it gets the hash set, the settings, and the SRS. And then, using the EZKL client-side engine again, it calls prove and creates a proof. And then what we're doing in Zupass is we compress that proof and we cut it up into a bunch of slides and we create a GIF QR, which is something hopefully we'll get to see. This is how verification works. So the scanning user scans all the slides of the GIF QR and then reconstructs the EZKL proof. Passes that to the EZKL verify function. It'll get the VK verification key, the settings, and the SRS from local storage. And then it'll test, is this a valid proof? So if it's a verified true, then we know that the PCD holder is a set member. The other path that could happen is it verifies to false. Now, in this case, maybe the stuff we got off local storage is stale. Maybe this person registered since we got these artifacts. So we'll go to their set membership server, and we'll get everything we need, our verification key, our settings, our new SRS, in this possible stale state. We'll run verify again. Now if it verifies false a second time, we know this person doesn't belong. If it verifies true, they belong. Okay, let's see if we can do a demo. So this is my fork of Zupass. And I should have deleted these. Run this. Okay. So I am going to create these PCDs. I'm going to give it my secret. So what's actually, what's happening here is it was using EZKL to generate that hash. Sometimes that can take a little time. We'll now make a display PCD for that secret PCD we just made. So now, if we go back to Zupass, we should see our PCDs. All right, cool. So I found that the best way to demo this is with my iPad. Let's see how this works. So, what's that? Yeah, I have it as a monitor. Let's see if this works real quick. So it's creating the membership PCD. It may need to download a bunch of stuff, and depending on the Wi-Fi, it could take a little time. So this is the GIF QR. There's more data in our EZKL proofs right now than can really reasonably be encoded in a single GIF. So this is the solution we came up with. And by we, I mean Ivan suggested as a joke and actually worked. So that's been fun. Okay, so now I have it on my iPad. Still trying to get a hang of the screen arrangements here. So what I should be able to do is now send this back. Now some bouncer, gatekeeper, they go to the passport, Zupass, and they use this scan GIF function. And you cannot see it. There it is. So, all right, so there it's grabbing all the slides. Sometimes the last one takes a second. All right, great. So this person belongs. Now, through a little hack here, I'm going to reset the server. Okay, great. So this user has PCD, same ones that we just created, but now I've reset the server, so the set, and if we want to be totally sure that everything works, let's just see if it works. I think it's going to work. Okay, get over here. So this user is going to show the same PCD, but it should no longer be in the set because I just told the server to start all its stuff over. Taking a second to prove. Sometimes it takes a while. Well, usually it goes faster than that, but maybe I can talk about the next slide while this is coming up, and we can come back to it, or not, whatever we want to do. Alrighty. So I go to the left, right? No, I go to the right. There's my cursor. Where was all my tabs? Here they are. Sorry, this 3 monitors thing is confusing. All right. All right, I'll let that do that thing, and then I'm over here, and here's the presentation. Great. Okay, so literally, it always works this way. That right when I switch back, it loaded. Okay, so, all right. So now, what we expect. All right. You're sus, you shall not pass. And so we can see that this guy doesn't belong. Now, I want to show you the end of my presentation. Here we go, to the right, awesome. To the right, yes, where's my cursor? Slideshow, thanks for bearing with me, guys. So, where were we? So, that was the demo. And what does this mean? What's the impact? Okay, now we can program ZK circuits using scripting languages like Python or JavaScript with something like TensorFlow, JS. We can use pre-trained models off the rack to build our ZK applications. This allows us to expand the problem set we can solve, we can prove and verify with ZK. One thing that would be interesting is biometric models such as facial and speech recognition models. And then other AI stuff. So, I was talking to Richard yesterday, and this PROGCRYPTO thing has been a huge hit and is really exciting. And we were saying, how cool would it be if you could take a picture of one of these cats running around Istanbul, and then you could identify that cat and create like a feature vector for that cat that then becomes a cat PCD. So what if we had like a real cat Pokedex PCDs? That would be fun, right? Oh wait, a demo? Okay. So just to show you how simple this is, an hour ago I told ChatGPT that I need you to build me a PyTorch model to classify cats. So I went to Kaggle and I downloaded some cats. And then, oops, where is it? It's in here somewhere. Which one? Third one. Oh, that part, but I was going to show the notebook. Anyway, so I was going to show the copy. Well, it's actually fine. Yeah, ChatGPT told me this is how I do it. Turned out it was 100% right. So I created this model, and then what I wanted to do was compile it with EZKL and put it on our hub. So I let it, oops. Whoa. So here's my cat identifier model. I can get the solidity verifier right here, and I can use build applications that use this backend as the prover. Theoretically, I could also put this model, I could compile it client-side, and then similar to the application flow I just showed you, I could do it all client-side in Zupass. So been really excited to see not only like set membership, but all these other cool things that Zupass is allowing people to do, and had a really appreciate the conversation yesterday. It was really inspirational. I'm like, man, we could do so many fun things with this. You know, you could take the feature vector for a cat and then pass that to some generative AI to create art for that cat, so everyone has like the same Pokemon card associated with the cat that they took a photo of in real life. So really cool stuff. And then we want to reduce proof size and time, reduce artifact size, and just make the experience better for JavaScript developers to use our EZKL engine package. So lastly, just want to say thank you guys for coming to the talk, and thank you to Xerox PARC for hosting such an awesome event, and specifically to Brian and Ivan and Richard for helping me so much to figure out how this repo works and bootstrap EZKL into it. So thank you all.